Okay, we're recording. So, Jacques, if you want to take over, please go ahead.
Hi, I'm Jacques Pinard, and I'm a postdoc based at the University of Massachusetts, and I'm working in the QBism group with Chris Fuchs. I'm not sure if I should. I won't say much about my academic history, except that I've always been drawn to foundational questions, and I went through something of a shopping basket of interpretations before I found QBism. And, you know, based on that history, I'm still not sure that I would commit myself with any certainty even to QBism. But for the moment, I definitely think it's the most interesting and productive way to go. And I'm very happy to be talking to a group of people who are quite comfortable discussing issues of consciousness in quantum theory, because I think that's exactly what makes Foundation so exciting. So yeah, thanks for having me. Shall I share a screen?
Yes, go ahead.
Okay, just a minute. Okay, hopefully you can all see this.
Yep.
And here I've chosen for today's talk one of Picasso's lesser known light drawings. You can see there Picasso using the movements of his own body to make it. And one of the things I'm going to try to argue by the end of the talk is that mind is not something that's locked up inside our skulls. It really is something that goes together with the world out there as well. And I like this picture because there you can see Picasso's artwork is really physically outside himself, but it's connected to him through the movement of his body. So there's a vague relevance to my talk there, but I'm getting ahead of myself. So I'd like to begin with a really simple question. Why is the interpretation of quantum theory so controversial? And I know that there have been many other controversial things in physics. I mean, even Einstein's theory of general relativity was surrounded by controversy at the time. But I think there really is something about the interpretation of quantum theory that gets under the skin of physicists more than usual. And I think the reason is that unlike all previous theories in the history of physics, quantum theory really forces us to talk about consciousness. And that's something that physicists are quite uncomfortable doing because we haven't had to do it before. And it's really not our domain. None of us studied psychology, and many of us chose this profession because we wanted to avoid psychology. So why is that? Why does quantum theory seem to force us in that direction? Not everyone would agree with me, but I think those in this group probably are sympathetic to this. And I think Marcus in his talk last time gave one of the previous times gave a pretty good argument that this comes from the measurement problem. So I'm rehashing a bit what Marcus argued, but essentially the issue is that we can no longer keep separate the observed facts from the mode by which they were observed in quantum theory. And the mode by which we observe things just cannot be talked about without confronting consciousness, because you can't observe something if you're not aware of it. So let me just give and I must say this talk I'm going to try to keep it relatively short. So I'm not aiming for perfect rigor in the things that I'm saying, but if you like, you can quiz me on details afterwards. But as a kind of general overview, the measurement problem boils down to the fact that on one hand, we only ever experience one measurement outcome. Indeed, by definition, if experiences of measurement outcomes are meant to be mutually exclusive, otherwise they wouldn't represent alternative possible things that could happen. And so by definition, you can't experience mutually exclusive experiences. But on the other hand, quantum states are generically superposition states. So on paper, at least, they represent simultaneously multiple possibilities, and they must somehow collapse to a single definite outcome upon measurement. So the tension between these two is the measurement problem, in essence. And to give an account of our experience, as all physical theories must do, we need to understand what role consciousness plays in the quantum formalism. And in particular, we have to understand the nature of this collapse. And historically, and here I'm definitely glossing over many nuances, but I think you can more or less divide the approaches into three categories. The first is denial. You can just deny that measurement happens at all. You can say, well, you might think that you're seeing a single outcome, but there's another copy of you seeing mutually exclusive outcome, and actually no measurement actually happened. It's all, measurement is just an illusion, I guess. So I'm not really going to talk about that one. I guess you can tell I'm not too sympathetic to it. The second option is you can say, okay, well, measurements happen, so that falls into the domain of mind stuff. So that they're our awareness of things we're aware of in our minds, like thoughts, intentions, etc., belong to one domain of things, and then there's another domain of things that's the stuff physicists usually talk about, which are tables, atoms, and so on. And we've got these two domains, and they need to talk to each other somehow through measurement. So measurement is somehow the interaction between mind and matter that causes our experience. The thing out there impacts our senses, and through our senses, somehow it enters our awareness and causes an experience. So that's what I'm calling dualism. And I'm going to try to argue that QBism is aiming towards a third possibility that doesn't fall into the dualism category. And this is certainly not obvious to probably many people, even who know much about QBism. So I think it's worth trying to explain why I don't think it's dualism. I would like to say, though, I'm not going to, Ken put the title of my talk as a QBist mind matter theory. I'm not presenting a theory here. I'm just going to make some comments about what such a theory might look like. What are the general principles that we could use to get to such a theory. But let me just take a brief detour, because my mention of dualism may have made you think, is he talking about Descartes? Indeed. I propose that this shifty split, that was Bell's derogatory name for, where does the collapse happen in the measurement problem, the shifty split. I'm going to argue that this isn't something new. Quantum theory we weren't the first people to discover this problem. This is just a manifestation of a very old problem, which is Descartes' famous split between the immanent and the transcendent. Immanent being the mental phenomena, things in consciousness, our thoughts and so on. And the transcendent being the stuff out there in the world, the material stuff, matter. And Descartes argued that indeed everything that exists falls into one category or the other. They're mutually exclusive domains. And the transcendent realm impinges upon our senses and is conveyed to some place specific in the brain. He thought it was the pineal gland, the so-called Cartesian theater, where sensory information is somehow converted into things in our awareness, representations in our awareness. And here's a little diagram. You can see over there, he's got information coming into the eyeballs and going through the brain to the pineal gland. And over on the right here, I've got the diagram showing how schematically you can represent this picture as having mind and matter as two distinct but equally fundamental domains, which then interact via this mysterious lightning bolt in the brain somewhere to give rise to experience, which is then derived in the sense that it is caused by and arises out of this interaction. And this immediately gives rise to a kind of Cartesian measurement problem. So how exactly is it possible for physical phenomena to affect mental phenomena through this mysterious lightning bolt? And that indeed troubled philosophers for a long time. And from what I can tell, they more or less gave up on trying to make sense out of it. So what happened historically, from what I could tell, is that they tended to take one or the other horn of the dilemma. So they would either tend to push everything into the immanent side or everything into the transcendent side, so as to avoid having to deal with the tricky boundary between the two. So you ended up with idealism, which essentially says that only mind exists, with proponents like Berkeley and Rorty. Or on the other extreme, you get physicalism, which, borrowing from Democritus, the slogan, it's all atoms and the void. And, you might think that you're conscious and so on, but consciousness is emergent or it's an illusion. Everything that really exists is only physical stuff. And most physicists have tended to subscribe to that view, I think. But a few brave souls in philosophy have suggested a third option, that maybe the joker in the pack is the assumption that mind and matter are fundamentally separate domains. We should reject this Cartesian split. And there you get non-dualist philosophies where mind and matter are not fundamentally separable. We cannot conceive of one except in relation to the other. And I've left the Y of Merleau-Ponty's name there, but yeah, Merleau-Ponty and in general the continental phenomenologists, Alfred North Whitehead and William James, each had philosophies that I would put into this non-dualist category. And you can probably guess that I'm going to try to put QBism there too. But you might say, why? Hold on a minute. Why can't we just stick QBism in the dualist category? Because those of you who've read a little about QBism might say, well, in QBism, it says that you have agents and they take actions on the world. So there's your mind component and your matter component. And this results in the agent having an experience. So that sounds exactly like that little schematic I did for dualism. It seems like on the face of it, QBism should fit pretty neatly into that box. So in order to explain why I think it doesn't, and again, this is elaborating somewhat on remarks that that Marcus made, let me talk a little bit about QBism's path. So this is not meant to be a completely accurate historical representation of QBism's development, which was much more convoluted, but it serves as a kind of a conceptual tour guide that tells you how you could get to QBism by making a series of conceptual decisions. So the starting point for our journey towards QBism is to notice something which probably everyone notices when you first encounter quantum theory, that these quantum states behave really similarly to probabilities under certain circumstances. And particularly striking is the phenomenon of collapse of the wave function, which when you think about it, just seems a lot like I'm just updating probabilities. It's like the famous example of when, there's a lady whose husband goes to war and is killed in the war, and she instantaneously becomes a widow, even though she doesn't know that she is one. It happens instantly, faster than light, but there's no paradox there because it's not a physical thing that's collapsing. It's just a probability that you update when you find out. So this is really tempting because it says, well, if we can think about quantum states as having probabilities in them, that might explain away this apparent non-locality. Except that, as we all know, quantum theory isn't quite the same as classical probability theory, because there's things like quantum interference, and you can't get that just by adding probabilities together. You need complex numbers, it seems. So what is to be done? And one path is to say, well, as much as we'd like to say that we just have to give up, in fact, quantum states do describe something real. They're not describing our knowledge of the world. They're describing something out there. And the superficial resemblance to probabilities is just accidental, or maybe has some convoluted explanation. But QBism takes the other path and says, we're going to take this idea seriously and see if we can understand the wave function as being, at least in part, dependent on our knowledge of something, having some epistemic component. And that leads us then to the next natural thing to do is to separate out the epistemic part. So you say, well, if quantum states are at least partly epistemic, we should be able to figure out which part is epistemic, and then whatever's left over, what I'll call the ontological residue, will tell us something about the world out there, separately from our knowledge of it. E.T. James had this great quote where he talks about unscrambling the omelet that was made by Bohr and Heisenberg. And he was one of the champions of this idea that quantum states are epistemic in character. But the key question, if we want to separate this omelette, we have to ask ourselves, if quantum states represent our uncertainty or knowledge about something, then what is the something? And here again, we have a split. We could go with Team Einstein. Einstein in the EPR thought experiment famously argued that quantum theory was an incomplete description of reality. And the idea there is that the quantum state represents our uncertainty about some real state of affairs, which later has been dubbed a hidden variable model. And again, maybe it should come as no surprise that QBism rejects that idea. We're not in favor of hidden variable models. We went with Team Bohr, who says, well, it's something else. Quantum theory is not incomplete. It is as complete as it could be. There isn't something there about which, quantum states are still epistemic. They still represent knowledge, but it's not knowledge about some pre-existing fact. Now, before I follow QBism, I just want to say a few more words about the Einsteinian viewpoint, because there were some interesting physical developments on that in quantum foundations. So after, much after the Einstein-Bohr debates, Harrigan and Speckens came along, I think it was in 2000, I'll get it wrong, 2012 or earlier. But they wrote a paper where they formalized Einstein's intuition based on a number of things he had written. And they gave a picture like this. Imagine that the wave function determines some probability that represents our epistemic knowledge or uncertainty about the real state of affairs, which is represented on this horizontal x-axis. So x here are the hidden variables. The true state of reality is some particular dot in that configuration space. And the wave function just defines a probability over that. And then when a measurement happens, we're simply finding out or revealing what the pre-existing value was. And so after the measurement, we observe something different, and we infer that that's what there was before, and we update our probabilities. And these are called psi-epistemic hidden variable models. And I just want to mention here that this fits pretty well the pattern of dualism. If you were a dualist, this would be a pretty neat way of understanding quantum theory. On the left side here, you have the transcendent true state of affairs in the world, a mind-independent truth, which is the pre-existing unknown value. And then through measurement, that impacts our measurement apparatus and then our senses, and we become aware of the true value, and we can update our mind. In this case, we update our knowledge to certainty. Unfortunately, fortunately for QBism, they dodged a bullet by not accepting this story. But unfortunately for Einstein and those sympathetic to this point of view, it turns out that these models actually cannot reproduce all the predictions of quantum theory. And I think there have even been some experiments which have confirmed that, in fact, nature does not subscribe to these theories. So these are actually, they don't work. They don't give you quantum theory, and the theory they do give you is not experimentally validated. So these days you find very few people, if any, who subscribe to this point of view. But of course, that does raise the question, well, if that isn't the story, what is the story? And if we follow QBism after Bohr, we're going to say that the wave function represents epistemic knowledge, but it's no longer knowledge about some pre-existing state of reality that's just waiting there independently of us to be revealed. There is no there, as Wheeler once said. I think he said it, but I think he was quoting someone else actually. But the idea there is that the epistemic knowledge that you have it's not about some state of reality independent of you. It's your uncertainty about what you will see when you do the measurement. So it's uncertainty about a future observation. So in this case, after the measurement, you do still get an observed value. It's just that you can't say that what you're observing was there before you observed it. So this is what the QBists like to call genuine novelty, that something new actually comes into the universe in the act of observation that wasn't there before. And that kind of forces us to conclude that the ontological residue, once we strip away the wave function, which is all epistemic, we're just left with the actual observation acts themselves. It's the measurement outcome just in the moment that it is observed. And I'm just going to skip there. We can come back to that if you like. I mentioned, so there is a discussion of, well, if the wave function just represents probabilities, how do we account for interference effects? And QBism has a way of doing that using only probabilities without complex numbers. But I don't want to distract you with mathematics just yet. If you want to talk about that, let me know and we'll come back to it at the end. I want to continue to the next fork in QBism's path, which is this question of when, basically we're now that we've followed QBism to this point, we face the measurement problem in all of its glory. Because when do we say that an observation has occurred? If these observation moments are meant to be the core of an ontology, we have to be able to say what an observation is. What are these future events about which we're uncertain? And Bohr famously said that observations were irreversible amplification in devices whose design is communicable in common language, suitably refined by terminology of classical physics, etc. The problem that QBism has with that response is that QBists feel that it does not adequately answer the Wigner's friend paradox. In other words, when you observe an observer, it seems that Bohr's recipe doesn't tell you what you should do. It doesn't tell you what counts as an observation and what doesn't. So let me try to explain why Bohr is unsatisfactory in this case. So the Wigner's friend thought experiment runs something like this. Suppose that I make my observation inside a closed laboratory, and we can assume that my observation satisfies all of Bohr's desiderata. So, if there's other people in the lab, I can communicate my results to them, and we can check our lab notebooks, and we have a macroscopic measuring apparatus and all of that. And let's just imagine all of that's happening inside the laboratory. So it seems per Bohr that this should be sufficient to qualify as an outcome that actually happened. The problem comes when we consider somebody outside the lab, and imagine the lab is, hermetically sealed and isolated from other systems so that it can't decohere relative to someone on the outside. Now, there's a tricky thing here because in principle, the results of that experiment are still communicable to somebody outside. We could just open the, break the seal and have the information get sent out as to what the outcome was. But in fact, we're assuming they are not in practice communicated. And this subtle difference between whether a measurement result is communicable in principle versus whether it's actually communicated, so far as I know, Bohr doesn't seem to appreciate the importance of that distinction. But it really matters in this case, because if the result is not actually communicated to someone outside, if the lab remains sealed, then they have every right to use quantum theory to describe it. In fact, they should describe it as a coherent entangled superposition of the people inside who are, after all, made of matter and therefore can be modeled as quantum systems. They should then be in an entangled superposition of obtaining all the different possible results. And indeed, someone outside the lab would expect to see interference effects or be able to coherently undo the measurement and all sorts of things like that. So we have a situation where it seems that Bohr's criterion would say that a measurement has happened for people inside the lab, but it's not clear whether that extends to the person outside. And indeed, if we did so, it would seem to contradict quantum theory itself. So here we have the choice to make. Does the measurement inside the lab count as a measurement for somebody outside, even when the lab remains sealed? And we could just bite the bullet and say, yes, when you have a sufficiently macroscopic system and conscious observers and whatever, then it really collapses the state for everybody in principle. So somebody outside the lab cannot describe it as a superposition anymore. And this falls into the category of objective collapse theories. But it should be noted that these have to add extra dynamics, let's say nonlinear corrections to the Schrodinger equation and so on to make that work. So it's not just quantum theory, it's a modification of it. The alternative is to say, well, quantum theory continues to hold even at these scales. And in that case, we have to bite another bullet and say, well, the outcome does happen to the people relative to the people inside the lab, but it doesn't happen for the people outside. It's a kind of relativism about whether the measurement outcome has happened. And that's the direction that QBism takes. And you can see that by now we're getting quite deep into the woods. Relativism about observed facts. But this is still not deep enough for the QBists. We're adventurous spirits, because the foregoing actually only places a limitation on observations by relativizing them. But it doesn't yet tell us what an observation actually is. It hasn't made a positive statement about that. And here's where I think QBism is at its most radical, is in the answer it gives to what an observation is. It says that measurement outcomes are experiences of an experiencing subject, who they call the agent, who acts on a world external to themselves. So here we have a positive statement that ties the notion of observation very closely to consciousness. Agents now, in order to be an observer, to observe measurement outcomes, QBism is saying you explicitly have to be conscious. So that's the first consequence of this point of view. And the second consequence is that this experience, as I said, it implicates an active subject engaged with the world external to themselves. But we have to remember that this experience is to be taken as the primary ontological substrate, because remember earlier, QBism rejects the idea that there's some pre-existing variables that determine the content of the experience. So, we have the experience is genuine novelty in a sense, and it, whatever our ontology is, it has to be built out of these experiences. So they come first. I'm going to call this the experience first postulate of QBism. And that means that the experience cannot be preceded by some, subject and world, which are two separate, independent, pre-existing things. Instead, when we talk about the subject and the world, we have to understand those as emerging out of the experience itself. And here I'm definitely going beyond what QBism has ever said in the literature. So please consider all of this my additional speculations on top of QBist doctrine. But I would argue that what we have is this diagram on the right. So here I've taken the dualist diagram, which you remember that's on the left, and I flipped it upside down. So what we actually have, I would say, in QBism is a situation where experience is fundamental. And out of that experience, through some process of elaboration, the mind differentiates itself from the world external to itself. So the subject and the object, mind and matter, are concepts which are elaborated out of or constructed out of the medium of experience. So that I would say is, I'm arguing that is the direction that QBism should go if it's to build something like a theory of mind and matter. And I want to just clarify that this claim, this upside down diagram that puts experience first, it's not merely a methodological point, because yes, methodologically all inference about the subject and the world has to proceed from experience. That's a vacuous truism. I mean, we can't know anything about the world except through our experiences that we have. But I'm not saying that as a methodological point, experience comes first. I'm saying more than that. I'm saying that it comes first ontologically, metaphysically. So we do not come into the universe as ready-made selves interacting with a ready-made world. Who we are and what the world is are mutually contingent and continually evolving in response to each other. And that's why this is a fundamentally non-dualist point of view. So here I can finally put QBism in the third non-dualist camp, and perhaps this goes some way to explaining why there's QBism has close ties with the philosophy of the American pragmatists like William James, and also more recently the continental phenomenologists. But basically, I think QBism needs to say that experience is primordial. It has both mental and physical aspects, initially undifferentiated. And measurement is a reflexive process innate to experience, in which mind differentiates itself from matter. Now, just on the last two slides, yep, almost at the end of the time I wanted to take. So final two slides, no talk on consciousness is complete without mentioning the hard problem. And, that the hard problem, it's relatively easy to state. Essentially, it boils down to how can all of this, beauty, love, and things that I'm experiencing, the delicacy of the light falling upon the roses outside my window, how can all of that be nothing but the electrical firings of neurons in my brain and atoms and molecules and so forth? The trouble with that is when you examine it more closely, it's not clear that it's a well-posed question. And based on the point of view I've been advocating here, I think that we should say there is no such thing as matter divorced from any kind of experience. Our first encounter with matter is always as something which we separate out of experience. So the whole practice of science has always been about figuring out which parts of experience are just our own subjective biases and which parts correspond to something objective out there in the world. And this is a continual and historically evolving process. So I would say that a priori, the nature of all matter is that it's something that's always embedded in experience. And borrowing a little bit from Merleau-Ponty, I would say the nature of all matter is that it can experience and can be experienced. And maybe this takes me pretty close to some kind of panpsychism. I guess I'm okay with that. And I think it brings a benefit here to the hard problem of consciousness, because it means that the puzzle of how mind and matter can be connected is a pseudo question, because it presumes that they belong to completely separate domains. It has hidden in the posing of the hard problem of consciousness is that old Cartesian split. If we reject that split, we dissolve the hard problem of consciousness. We already experience mind and matter as connected. We only need to take our experience more seriously. What I mean by that is if we take seriously our experience of mind and matter as being a priori connected things, and that observation is really an act of separating out the mental aspects from the material aspects, then we reframe the hard problem of consciousness into a more tractable problem, which I'm calling here the not as hard problem of consciousness, or maybe you could call it the still pretty hard problem of consciousness, which is what specific subjective experiences accompany specific patterns of neuronal activity in the brain. So we're taking for granted that the two are connected. And now we want to investigate the contours of that connection. And indeed, this is precisely what neuroscientists already study. They try to figure out when someone's having such and such a subjective experience, what does that correspond to in terms of the electrical activity in their brain? And that's a really fascinating and definitely scientifically well-posed and tractable problem. So a way that I put it in using an analogy, once you stop worrying about how archery can be possible given Zeno's paradox of the arrow, then you're free to get on with improving your archery skills. So once we see the hard problem of consciousness is a non-problem, we can get on with the more interesting issue of figuring out how consciousness and matter talk to each other. And that's the end of my talk. So thanks for listening. Open to questions.
Positive reaction.
Very interesting.
Can I ask a question? Oh, there are several already. Okay.
No, go ahead, Johan. Go ahead.
Yeah, well, thanks for this fascinating talk. I see a contradiction. If you say a measurement is an experience of a subject, okay, I agree with that. Wouldn't you then immediately also say that the measurement of Wigner's friend in his box has actually happened? So, or put it the other way, if you want to avoid idealism, that I'm the only existing entity, experiencing entity, and you seem to wish to avoid this problem, right? You must postulate many experiencing entities. And then that implies that Wigner's friend really has the experience of a measurement, and that implies ultimately that somewhere quantum theory must break down.
So I agree with all steps in your argument except for the last step, the step towards saying therefore quantum theory breaks down. So, but I think you raise a point which is perhaps at the moment a sore point of interpretations like QBism. So, in fact, QBism is not the only one which says that observations are relative to the observer. There's also Rovelli's relational interpretation, which says that. And all of these interpretations have recently been attacked for the reason that you state, that it seems difficult for them to avoid idealism. It seems, and at the same time to uphold that quantum theory doesn't need to be modified. So in this case, all I can say is that I think that it is possible to consistently maintain the linearity of quantum theory and the idea that facts are relative. However, doing so is by no means simple. Perhaps the most I can say is that I hold out hope, but I don't have an answer yet.
Marcus or Nathan, I don't know who's first, just somebody. Go ahead.
I think Catherine was.
Hi, Kathy Lasky. Really fascinating talk. Thank you so much. I had a couple of, first a comment that probably doesn't even require a response, but you may if you'd like, and then a question. So my comment was that you had this slide where you had the many worlds interpretation, and then you said, so maybe consciousness, or maybe collapse and consciousness is an illusion. And I'm trying to understand why consciousness, in the many worlds interpretation, I don't understand consciousness to be an illusion. I understand there to be many different worlds, and at each branch point, there's a consciousness. There's a consciousness in which I observe spin up, and there's a consciousness in which I observe spin down. Not that it's an illusion, but there are lots of them, which again has its own problems. But then the question is that you said objective collapse theories don't conform to quantum theory. They require you said they have to add extra dynamics. Can you explain what you mean by they have to add extra dynamics?
Yeah. So first, let me comment on your comment. You're right. I was pigeonholing many worlds a little bit there. A more careful statement is the following: that in many worlds we kind of postpone the measurement problem, and later on it comes back to haunt us. So at some point, as I said right at the beginning, your theory has to tell you how it connects to things that we observe. And when many worlds finally gets around to trying to address that, it runs into problems. Now, one option is to just say consciousness is an illusion, but there are many other possibly much better answers, such as the one you mentioned. And these tend to be one of the things that many worlds people argue about among themselves, is how best to do that. So yeah, I did kind of gloss over that detail. But to answer your question, so basically it boils down to the fact that if we just take a sort of naive or at least straightforward application of quantum theory, an isolated system in a pure state should continue to remain in a pure state and therefore should not collapse. So in the case of the Wigner's friend, quantum theory taken in its most straightforward application would say that the system should become an entangled superposition of the friend with the outcomes. In order to say that it doesn't, you would need to argue that there is something about that state, for example, the fact that it is macroscopic, or the fact that it contains a conscious entity, or some ingredient like that. You would have to invoke that and explain why that creates, what is the mechanism whereby that ingredient prevents this state from becoming a coherent.
Okay. So then I
That's
think
all
what
that
you're
I
not
meant.
saying is that it violates
said-
quantum. You're not, yeah, I think my understanding is
right.
you're not saying it violates quantum theory. You're saying it's incomplete because it doesn't specify when this collapse occurs and which operator gets applied when it occurs.
Yeah, perhaps my phrasing was a bit too strong. More accurate would be to say that you would need to say more than what quantum theory currently says. You would need
Quantum
to
theory
add,
is incomplete. Okay.
you need to
great.
add to it. I won't go as far as saying that it's inconsistent with quantum theory. That would be too strong.
Okay. I just wanted to clarify that. Okay. Thanks for a great presentation.
Nathan, would you like to say?
You have to unmute your
Nathan, you're
microphone.
muted, Nathan.
No, I'd be happy to, unless Marcus would like to go.
No, I think you're first.
You're
I'm
first.
sure you're first, actually.
Well, then let me thank you for a wonderful talk. I found the arguments extremely lucid and clear. And so I just have one question. If you wouldn't mind, or I don't know if you're able to go back to the quote from Bohr, giving the definition of measurement.
Yeah. Get back there.
Let's be a little careful. That may not be a quote of Bohr. Did you take it from one of my papers, Jacques?
I did. I took it from your
Yeah.
notwithstanding Bohr paper.
Yeah.
And you
I
put
a
it in quotation marks.
Didn't I say Bohr said something like this?
Maybe.
So it was a bit of a composite of all the things that Bohr said. So,
well, that explains it, because
it's
I
not
was
really
looking,
a verbatim quote.
because I couldn't find a verbatim quote, and so I was like, but I know I've seen that somewhere, and then I was like, oh yeah, Chris's paper.
So, but you can find bits and pieces of that everywhere. So I thought I wasn't too inaccurate.
But Nathan, go ahead. What did you want to say about it?
Well, I think this is crucial. I hope that between you and Chris and I, we can find just the right quote or the right reference. Because I guess I've tipped my hat that I agree with Bohr wholeheartly, that the core concept of the measurement is the process of this irreversible amplification of what otherwise would be a quantum signal and a reversible process. And so my question really is, how in your model you aim to reconcile the definition of measurement as an irreversible process with your construction of the laboratory as a closed system?
That's funny, because that's the question I would put to you as someone who endorses Bohr's answer. My point here was that QBism rejects this idea of it being an irreversible, et cetera, et cetera. QBism would say, well, perhaps it is reversible for someone outside the lab with a, giant apparatus that can coherently disentangle the one system from the other.
So I guess this is my concern. When you set down the assumption of the laboratory as a closed system, I mean, I'm happy to accept this as a counterfactual argument, as something that we know in physics actually never happens. But arguing counterfactually, I don't see how that then lends itself to produce an actual model of measurement when you've begun with the model of measurement that is inconsistent with what we always see in the laboratory.
I'm not sure I agree with you that the QBist model of measurement is inconsistent with what we always see in the laboratory. You would have to
then
convince me.
here's my question. How do you create a laboratory that doesn't allow photons to escape into the vacuum or the universe at large?
Oh, okay. Well, I think an answer to that is that you don't need to control and isolate all degrees of freedom in order to see quantum effects. You just need to control decoherence sufficiently in the degrees of freedom that you're interested in, and then you'll see quantum effects in those degrees of freedom. So the plausibility of the Wigner's friend argument it doesn't rest on the idea of having an absolutely sealed and screened off laboratory. So it's not in principle impossible. We might still allow for things, we know that gravitationally, it's generally accepted that you can't shield gravitation. So there'll always at least be gravitational decoherence, but we can neglect it so long as it's sufficiently small. So through arguments like that, at least I personally am convinced that it makes sense to take seriously this thought experiment.
I understand. And in fact, the experiment you've described has been performed. But the concern is that whether the experiment you described actually contains a measurement as the key act. And I would say that by definition, if you have made those decoherence processes of interest, again, not making the whole lab immune to decoherence, but the processes of interest, if you've made them, minimize them, essentially making the process reversible, then by construction, you have guaranteed that a measurement cannot occur, because when we build a detector, the whole concept of the detector click, as they say, is to maximize in some sense the decoherence when the detector click occurs. So you see my dilemma.
When you say that this experiment, as I described it, has been done, I would say it certainly hasn't, but perhaps you're thinking of the experiment that was done in which the role of the observer is played by a single photon. Is that the one you're thinking of?
Well, this is it. There was one by Howard Wiseman's lab that was a Nature publication, and another in a Science publication as well.
Yeah, so that I don't consider that to be a true Wigner's friend experiment, because we've got no reason to think that photons have experiences, or so it really doesn't pack the same punch that the experiment I described would.
Exactly, but this
however,
well, go on, please.
Having said that, the fact that I outside the laboratory with all of my fancy equipment might feel pretty certain that I can reverse this whole process and disentangle the wave function and let's say coherently undo the measurement. This is just a statement about what I believe I can do with that system. And therefore, if I, let's say, measure in an interference basis, I feel certain that I will get a click at the relevant detector. But none of this says anything about what the subjective experience is like for the person inside the laboratory. And I think it's perfectly consistent to say that they might be perfectly sure that they have seen a definite outcome, that they're not in a superposition, and they might even be pretty sure that, when I do my experiment, I'm going to fail to undo their measurement. So the thing is that you have to remember that in QBism, quantum states don't describe states of reality. They're epistemic. They represent our beliefs about what our future observations will be. So there's not an inconsistency here that the two observers, one inside and one outside, will assign different quantum states. It's a bit like the twins paradox in relativity.
Yeah, so here's my question. It's interesting because I'm actually sympathetic towards your panpsychic view. I don't even feel that an observer needs to be in the laboratory for a measurement to occur. I'm happy enough for the measurement to occur strictly when the detector clicks. And I have the advantage of giving the talk on this next week. But without getting into that, my question is, how do you, if you're not prepared to go to the single photon case where we know it's reversible, then how do you deal with, at least my understanding of what a measurement is that a single photon hits the detector, hits the photomultiplier tubes, an electron escapes, there's an electron cascade, and ultimately a quench. As the detector resets itself, gives a little click, and that click escapes into the universe irreversibly, never to return. So I don't see how you can escape from my irreversible definition of a measurement in an open laboratory without reconstructing the reversible system in the recent experiments with the photons that you also reject.
Well, not wanting to take too much time out of the remaining questions, I will just say that it seems to me that you're talking about an impossibility in practice as opposed to one in principle.
Indeed.
And I think that that what we have here is an impossibility in practice, but not in principle. And that
So
makes all the difference.
We've come back to the old debate
But,
between Plato and
yeah.
Aristotle. No, that's my pleasure.
I'd like to hear from Hakan.
Yes. Hi. Thank you. Thank you so much, Jack. This was
Wasn't Marcus next?
Oh yeah,
I'm sorry, I
Marcus has
hope
been
you
sitting there
Okay,
for ages.
it's fine, Hakan. I changed my mind and then I changed my mind again.
so. Okay. Should I? Are you sure, Marcus?
Mhm.
Okay. Yes. All right. I know. Okay. So yeah. Thank you so much. This is really interesting talk. And as usual, very thought-provoking and so on. But I just wanted to ask, well, I think I have a couple of questions, if that's all right. The postulate that the measurement outcome is an experience of a subject who acts on the world external to themselves. Now, I mean, it just reminded me of Gustav's explanation about spider and spider's web. There you see a tiny spider with a giant web, but the web is still part of its body. As soon as something touches, therefore it feels it. And similarly, how would I distinguish the outer shell of electron of my finger from the air molecule that is touching that finger? Similarly, consciousness, I'm using this word, but you know, there is uncertainty in every word, I think. So, but consciousness, can I really fit it into my skull? Or is it bigger than human body? Does it exist outside me as well as inside me? So I'm really interested in, you know, everything you said. But are you talking about, I struggle how to separate internal from external. So are we talking about some sort of Heisenberg's cut here? That's, you know, what is internal, what is external? That's the first question about the postulate. And the second is, if I understood you correctly, that I think probabilities are like kind of state of mind in QBism, if I understand you right. So, you know, Marcus just said he's changed his mind. He was going to ask a question. So different people, different minds observing same thing. I am a bit puzzled, but I am really intrigued, I must say. So with all good intentions, I'm wondering, you know, what's your answers? Thank you so much.
Well, yeah, thanks for the questions, and it's difficult to give you answers because these are things which are, I think, actively under consideration still. The point you make about internal and external, actually that word external, both of these words are actually problematic when we are in the context of a non-dualist way of thinking about consciousness and matter. And actually there's a nice quote from a book on phenomenology that I quite like, by Dan Zahavi, where he says something like, phenomenology plays havoc with the notions of internal and external, because in fact everything that we consider to be external is in some manner also internal, and vice versa. So I think it would be better actually just to drop that language and find another way to talk about it. We just haven't found the right language yet. Another point about, you know, the subject and, you know, where do you draw the boundary? Is it, you know, is it some kind of sharp cut? It definitely isn't sharp, and it's something which is evolutionary. So here, I think QBism has a close affinity, or certainly can learn a lot from looking at the psychology of development. For example, Piaget, how does the child come to identify itself as distinct from others? There's very interesting ideas there. For example, that the child does not initially, it can't tell the difference between its own body and another child's body. It takes a while for us to locate ourselves in the world. And in fact, it's a process which is continually going on and being tested. You know, if you undergo radical changes to your body, you have to renegotiate that boundary. You might have surgical implants or amputations or who knows what. So I think this is something that is constantly in tension, and it's contingent on what happens to us in the world. But that's all I can say about it. I have no idea how to make this more formal.
Well, I'll just say, I'm sorry, one more thing, because I have to go in a minute. I'm sorry, I'm teaching. So, I mean, would you say, you know, the ancient Greeks, that when you look at the Hesiod, his Theogonia, he talks about 9 muses, that is tragedy and poetry and astronomy and astrology and so on. And he says this all comes from the same mind, And then you have this Renaissance where the natural sciences completely separated from the social sciences. Is there any attempt in Cubism that sort of, because I think we are partly poetry, partly physics, partly mathematics. Is there any attempt perhaps in the future that reuniting this dissected human being? Because you talk about psychology, you bring in philosophy, you bring in so many things which I really intrigued by. Thank you. And I'm sorry for taking so much time.
Well, thanks for coming. Yeah, I mean, I'll just say, I think that definitely the spirit of Cubism lies in that direction towards a unification of different fields of human knowledge, but that's far more ambitious than anything that, you know, we like to just stick to physics for the moment. It's tricky enough as it is.
Any other questions?
I think 3 of us have other questions.
Yes, I would
Marcus has been up for a long time.
okay.
Yeah, well, there was just 2 points I wanted to make. One is that I should say that not all the people who call themselves Cubists don't all think exactly the same way. So possibly Chris and Jack will disagree with me here. I'm not sure. But certainly one of the attractions for Cubism to me is that it deals with this issue of what is a measurement in a very straightforward way. I mean, if you're talking about classical probability theory, no one asks what counts as an observation. How do you define it? Is it an irreversible physical process resulting in, I don't know, if you're doing observations in a hospital on epidemiology, the point at which somebody becomes ill or something? You don't have to define that. It's to do with your expectations. And, you know, from the point of view of applying the quantum theory, the issue of what is a measurement doesn't actually have to be defined. It's a point at which you decide you've learned something. The other point, and I think Jacques has said this in his own way, in many ways, but I'd just like to put it slightly differently, which is that one of the philosophers Jacques quoted, Rorty, once said the universe isn't sentence shaped, by which he meant that the universe doesn't correspond to a set of facts. And if you take a Cubist point of view, a fact is something quite limited. It isn't the case that the universe consists of a set of pre-given facts. A fact is something which you use in an immediate human context. I take it to be a fact that the president of the USA at the moment is Joe Biden, something like that. We don't extend that to the universe somehow consisting of a set of facts. I think that's quite relevant to thinking about the various issues that have come up. Anyway, just those 2 points.
Well, you do make me think that I may have been playing fast and loose with the distinction between a measurement outcome and an experience, because I think actually those are distinct ideas, but I kind of used them as if they were the same in Cubism. So that could perhaps be elaborated. Yeah,
I mean, there are some issues to elaborate there, definitely, and I'm not particularly wanting to be too committed to what I said. But...
Yes, I had, first of all, I want to join the chorus of everyone thanking you for most fascinating, compelling talk. And I want to thank you that you chose not to include the math in your presentation, particularly because as I listen to you and just looking at the ideas, it seemed to me like Cubism, I would say, comes close to trying to examine the laws of creation, if you will. And by that, I mean the question of how do you measure the immeasurable? I mean, that's built into the challenge of trying to treat it as science in a traditional sense, that QBism somehow sounds like it incorporates what I could best describe as maybe an invisible template of reality, an invisible template that all the measurable things that come with all our science are embedded or part of that reality. But the reality itself is an invisible template that supports those measurable entities. So how do you measure that which is actually part of what you're measuring in its being, so to speak? And because you didn't present the math, it allows me to perhaps ask you this whole science of fusion, because I'm intrigued by just the concept of fusion. That to me is like the reverse of reductive science, if you will. And I have no idea what the math is in fusion science, trying to bring measurable entities together and come up with something unique. But it kind of comes closest to my concept of trying to, how do you look at principles of creation? So my comment is just simply QBism, the adherents, like how does it as a science compare with the concept of laws to measure creation, of creating elements? And is there any similarity in the fusion science folk and the QBist science map that I was just curious.
So I have to first say that this is the first time I've heard of the concept of fusion science, but from what you say, I think I understand the spirit of the idea, and there is definitely a connection there. At least something I didn't really talk about is the concept of reductionism in science. And I think Marcus actually did talk about this a little bit and pointed out that there's something very anti-reductionist in QBism's philosophy of science. And the difference is that reductionism is a kind of eliminative approach to what is real. So with reductionism, you say, okay, I have thermodynamics and I have statistical mechanics, and then I observe that there's a connection between the two such that I can use statistical mechanics to explain thermodynamics, and therefore I eliminate thermodynamics from the domain of what is real in favor of just having statistical mechanics as the more fundamental. So we use the link between the two theories is used to eliminate one of them from reality. And in contrast, I think QBism is closer to an additive approach. So following a kind of William Jamesian philosophy of radical empiricism, I think William James would agree that we have thermodynamics and we have statistical mechanics, and these are both equally fundamental in a sense. And reductionism is just a special kind of connection between the two, in which statistical mechanics has a special place because it's far more universal. So it can be connected itself to a wider range of phenomena. But this by no means makes it more real or more fundamental than thermodynamics. It's simply an addition to our picture of reality. And so in that sense, I think that sounds a bit like what you're calling fusion science. I'm not sure if it is, but yeah.
Yes, thank you. If I could just add just a little bit, not to delay that, but I appreciate your response there, because it is reductive science that I have a problem with, and was thinking that perhaps QBism actually addresses, because even in reductive science, I've always been intrigued with the fact that you are essentially breaking things open and then studying the parts that you can measure that's there. But there's this whole arena of fusion would take in what is there that's holding those parts that are the results that you can measure, that escapes in reduction that you're not measuring. So that would be the immeasurable part of the reality that is there before you use energy to break it open, So what is it that has escaped? And that's kind of And what's escaped would be that part that if you reverse it and flip it upside down like you did in your equation, that part that escapes that you don't measure, because science only measures the product, but that keeps you, as Einstein would say to me, that keeps you at the same level of thinking at the problem. And really, as Einstein said, you have to go to another level of thinking to be able to capture that which escaped from the reduction that's not in the measure. And again, maybe some of the others, when I say fusion science, it's also from the naive part of folks that are dealing with kind of particle science, but where you put things together and create a new entity, as opposed to starting with a particle, breaking them open and getting the result. So the fusion is how do you make, that's why I said parallels to creation kind of science. Okay, but thank you.
Thanks.
And I'm intrigued with the QBists simply because they maybe are looking at it getting close to laws of creation, which is an aspect that intrigues me philosophically.
Anyone else?
Catherine has her hand up.
Oh,
Yeah, I'm not. We're getting close to the end, but I was kind of I wanted to go back to the question of measurement and the fact that quantum theory is incomplete and doesn't specify when a measurement occurs and which measurement operator will be applied, and that's the fundamental challenge as I see it with quantum theory. And I guess I don't see how QBism addresses that. We say measurements are experiences, but do we have any theory that says when we're going to have an experience? And then the other question that I wanted to ask was that we've got this setup where we're inside the laboratory and we've observed an outcome, and our friend is outside the laboratory and hasn't, and so it's still a superposition for them. In an objective collapse theory, they would still regard it as a superposition, but there would have been an objective outcome. And is there any way that you could distinguish between those two? Is there any way that you could say, well, okay, actually, it is still a superposition? Because it seems to me that if that person outside the laboratory ever saw the results, they would have to agree with the results that the person inside had seen, including what was measured. It's only the question of whether it can be rolled back. And I don't know how you would empirically distinguish. So those are the comments, and I don't know whether we have enough time to address them or not.
I noticed that Nathan put his hand up while you were talking. Were you planning to comment on one of Catherine's questions?
Yeah, well, I mean, I'm just thinking of this whole question of the experience versus the measurement. I mean, obviously, I come from a view that says that the measurement is not the experience, but I think the measurement is moot without the experience. And so my question or comment is, whether we've come to the question of whether a tree falls in the forest, does it make a sound? Or at the risk of mixing my metaphors, I might imagine a fancy car. I think most of us wouldn't suppose the fancy car stops existing when the driver gets out, but of course it's not very fun without the driver. And so this is my question, is whether that's similar to the relation between experience and measurement in QBism, but I feel I'm stealing Catherine's time.
Yeah, to add my own thoughts to that, the beauty of experience is that you don't need a theory to tell you when you're having one. It's kind of has the self-evident aspect to it, which I think is one of the things QBism takes advantage of, because it personalizes the usage of quantum theory to each user. It says, well, you get to decide whatever you think is an experience for you. You're the one who brings that to the table, and quantum theory is just something that you add to that to help you make decisions, but it doesn't tell you what you should consider to be an experience or not. That's your contribution. And this does lead to this kind of relativism that I mentioned, which is that because each person decides what's an experience for them and other people don't get to tell them that, If I see a tree falling in the forest, then it falls for me. But if you're far away and you don't know about it, or someone tells you on a phone call but you don't believe them, it's up to you to decide whether that tree fell for you or not, based on your own experience. Maybe you feel like you needed to see it yourself to believe that it happened for you, or maybe you're satisfied in trusting whoever told you over the phone. But again, it's up to you. So there, QBism does grapple a little bit with intersubjectivity. The question of, I think there is an interesting question to be asked. Well, how far does our experience extend beyond our direct and immediate perception? Can I, what sorts of things can I use in my experience to help extend the catalog of things that I judge to have happened? So there are some tricky philosophical issues there. But yeah, that's the most I can say about it now.
It seems, if I may be so bold, you're expounding on William James' ideas about the will to believe. That, the question of whether a tree falls in the forest doesn't enter my reality if I really don't care. It's just not a question that my experience is interested in.
Yeah, I think that's a fair way to put it.
Well, except that I mean, I think that gets dangerously close to, I don't know, if I'm in the lab and I make a measurement and it says that the spin is up, if you walk into that lab, right now it's still a superposition for you, but when you walk into that lab, you're not going to see spin down. I mean, there are some consistency constraints that we agree on. I mean, I think it would be, yeah, okay, so I saw the tree fall and you didn't see it, so it's still a superposition for you or a not happening to you and you don't care about it. But if you went to that forest, there's something really wrong with I think that part of being alive and part of being a scientist is to say that if you decided to come over to that same forest, you wouldn't see that the tree was still standing if I had seen that it fell. There have to be some intersubjectivity consistency constraints in our experience.
Usually.
This is a hot topic in the literature at the moment.
Well, I dare say that Chris Fuchs can comment on these questions of contextuality.
Yeah, but this is Jacques' talk. He's the spokesman for QBism.
Chris came because he wanted to know what my opinion is, because we don't talk enough.
Yeah, the question of intersubjective agreement and consistency between people is not only a hot topic, it's a well-discussed topic in subjective Bayesianism. And QBism rides on that wave. And I tend to think that consistency is overrated. What's important is that two agents occupy the same world, whether they agree or not. They can tell that they occupy the same world just by one hitting the face of the other, even though they never agree. So, but I don't want to talk about this now. Jacques should say his own things.
Yeah, I mean, I endorse what Chris says, that we must be careful not to make the sharing of an experience a slave to agreement, because agreement is really a much stronger thing. And it's commonplace that we share experiences, but we completely disagree about what they mean and how to express them in our symbols and whatever. So, but I do think that Catherine's is touching on something which does need to be elaborated further, because at minimum, we do need to have a notion of sharing experiences, of inhabiting the same world, even if it's one that we disagree about. And there is a question in QBism about how, if experiences are personal, how can they be shared? I tend to think that the sharing of an experience is not something that we deduce intellectually. It is part of the experience. So I follow a bit, there's a school of phenomenology which argues that there are experiences which are innately collective, things that we experience as a group. And it's not inconsistent to say, on the one hand, the way that I'm impacted by this experience is different from the way that you are, but at the same time to say we are both partaking of one and the same experience.
Einstein
we're in
really
deep-
wanted a hidden variables theory to be true, but he accepted or would have accepted or the experiments showing the violation of the Bell inequality. And that's how scientific change happens, is that things that people didn't want to be true and passionately believed weren't true, were the experiments overturned them, and then people said, okay. Now there are still people who will and also Sir Ronald Fisher and the smoking experiments as well. He didn't want smoking to cause cancer, and he came up with some, he tried to explain that there was something else that caused people both to smoke and to get cancer. And that theory was overridden by the data being so strong that you couldn't explain it by any other legitimate causal causal theory. So society kind of eventually was dragged kicking and screaming into agreeing that smoking caused cancer, and into agreeing that that hidden variables theories weren't true. And that has something to do with shared experiences. And agreeing to go by the results, science agrees to go by the results of our shared experiences.
I think I'd like to add that I do not, as I say, that I think there are some differences probably between me, Jacques, and Chris on this, but certainly in my own understanding of it, I can be a QBist, and I'm not committed to thinking that it makes no sense to talk about the tree in the forest falling when nobody sees it and when it's not part of anyone's experience. And certainly I have such beliefs that there are things happening that I don't see and no one sees. That is absolutely not committing one to a hidden variables theory or anything of that kind. I mean, there is a strong history in physics of trying to make some kind of global statement. So, you know, back in the 17th century, people wanted to say the universe consists of matter in motion. Some people nowadays want to say the universe consists of a state vector in Hilbert space. If you're a QBist, you don't believe in that kind of global statement about reality as a whole. You also don't believe that there's something called reality, which is identical to a set of facts that you know about it. It's much more modest, but it doesn't mean that you can only talk about your own experiences or other people's experiences, to me. But I probably disagree with Jacques on this.
Honestly, Marcus, I'm not entirely sure if we disagree or not.
No, I'm just saying no.
Well, I think we've come to the end of the discussion, unless I'm wrong. Anyone have something that they'd like to add? Okay, Jacques, well, thanks very much. We all appreciate your talk, and hope to see you the next round. See everybody next week.
See you there.
Yeah.
Good talk. Bye-bye.
Bye.